The next question is, at midday, that means 12 p.m., a motorboat A is 6 km east of a fixed origin. So without reading it further, we can just write this down. So the 6 km east means 6 km, and east unit is I unit, so that means 6I. So we can say, just let me write this down. So we can say here, let me write the information here. So the position vector of A is 6I. That's the first information that we have. So the position vector of the boat A is 6 km due east, means 6I. The next one is that it has a constant velocity of minus 4I plus j. So velocity of A is minus 4I plus j. We have these two information, the initial position vector of A and the velocity of A. Then we have at the same time another boat B is 3 km north of O. North means j, so 3 km north means the 3j vector. So OB is going to be 3j, so going up, and it is given that it is moving with a constant velocity of 4I minus 3j. So this is going to be 4I minus 3j. So we know the initial position vector of A and the velocity of A. We know the initial position vector of B and the velocity of B. So the next question is, show that at time t hours after midday. So here midday is considered to be the starting point. So at midday everything is 0, t equal to 0, t starts at midday. So remember that at midday the time starts. So at midday or 12 p.m. t equals to 0. That's where the time starts. Okay, so at midday we have to form the position vector of A is this. We have to show that, and we have to find a similar expression for that. So we have to find the present position vector. So let me review a little bit. If you remember, the present position vector is equals to initial position vector r0 plus displacement, which is velocity into time. So this is the formula for present position vector. So this is going to be, for A, the present position vector OA is going to be initial position vector 6I plus velocity into time. So the velocity is minus 4I plus j, and the time is here capital T. So 6I minus 4 ti plus tj. If you take the I common, it would be 6 minus 4 ti, and it would be tj. For B, the present position vector is going to be initial position vector 3j plus velocity is 4I minus 3j into time is t. So this would be 3j plus 4ti minus 3tj. If I take j common, it would be 3 minus 3tj. So this is the present position vector of B. So we have to show this, and this is done. The next question, we have to find the position of B relative to A. Now you remember, if it is B relative to A, that means you have to subtract it. So the next question is, let me do it here. So question number B is OB minus OA. So we have to find the position vector of B relative to A. That means OB minus OA. So it is going to be, so let me write this first, 6 minus 4 ti plus tj minus 4ti plus 3 minus 3tj. So if we break the bracket, it would be let's do one thing. Let's do this algebra very quickly. Now the coefficient of I is this minus the coefficient of I is this. So if I take I common, I can actually write it like this: 6 minus 4t minus 4t I. So that's what I did. I can write this I minus 4ti. If I take I common, it would be 6 minus 4t minus 4ti. Then next we have plus. If I take this one, tj minus, this plus into minus will become minus, so tj minus 3 minus 3tj. Now if I take j common by doing algebra, it will be j minus 3 minus 3t, and I can take the j common. So what this gives me is 6 minus 4t minus 4t is 6 minus 8t, and this is I, plus what this gives me, t minus 3 minus minus plus t 3t. So this would be 4t minus this j. So this is what we had to prove. Let's check. Is it 6 minus 8ti? 6 minus 8t, it's supposed to be 6 minus 8t. It is 8t minus 6, and it is 3 minus 4t. So this is 4t minus 3. So I think there is a change in sign. So what is the question? The question was find the position vector of B relative to A. So the problem happened, I took A first and B later on, so that's why it is reversed. So let me do one thing. This has to be first and that has to be later on. So if I correct this very quickly, since I made a mistake here, I took OA first and OB later, but it should have been OB minus OA. That's why it is reversed. So let me correct this very quickly. 8t minus 6 I plus 3 minus 4t j. Okay, so this is the answer that we have to prove. Now once this has been done, the next question is, by using your answer to part B, that means this, or otherwise, show that the boats would collide if they continued at the same velocities. Now collision means if two things they have to collide, that means they have to be at the same spot, both of them. That means their position has to be the same. So if I say both of them are colliding, that means the position of A, if they're here, so they are not colliding, there is a distance between them. So if this is A, this is B, so the distance between them is AB, which we found OB minus OA, that by position vector rule is AB. After all, collision means they are now in the same spot. So A and B is here. So if A and B is here, so what is the distance between them? Well, the distance between them is 0. So remember, if they collide, the distance between them is going to be 0, and we write it like this: both coefficient of I and j, they are going to be 0, and if both the values of t are same, then that means they have collided. If they are different, that means they have not collided. So let's do this final part. For I can write 8t minus 6 equals to 0, therefore t equals to 6 by 8, which means 2 3s is 6, 2 4s this, so t equals to 3/4. Then we can write for j, 3 minus 4t is equals to 0, so I can say t equals to 3 by 4. Now notice here, both the value of t, they matched, that means they collide, hence they collide. So remember this rule of collision. If they collide, they have to be at the same place. So the displacement, the distance is going to be 0. So the coefficient of I and the coefficient of j should be 0. Now if both of them match, that means they have collided. And you have to know the unit here. So the unit here is the time is in t hours. So if the time is in t hours, that means, and we start from 12 is the starting point, midday, so that means 3/4 of 1 hour. So 3/4 hour means, if you multiply by 60, so 3 by 4 into 60 is going to be 45 minutes. So they asked for the time. So the question was find the time. They did not ask for the value of t, they asked for the time. That means the clock time. They collide at, so 45 minutes means 12:45 p.m. That's when they collide. So you can write your answer like that. This question is about two ramblers. Allison and Bill, just A and B, are out walking at midday again. So t equals to 0 at 12 p.m. A is at fixed position O. If A is at O, that means, let me write down the information they have given us. So that means OA is 0 vector. So there is a vector called 0 vector. So OA is completely 0. So there is nothing here. And we know that OB, its initial position vector is minus 5i plus 12j. So OB is minus 5i plus 12j. Now we need the velocities. So they are both walking with constant velocity. Allison is 2i plus 3j. So velocity of A is 2i plus 3j. It was 2i plus 5j. 2i plus 5j. And B, for B, we don't know the velocity. We know that it has a direction parallel to this. Now, you know, if two vectors are parallel, that means one is longer than the other one. They are going to the same direction, but one is longer to the other one. So it is said that the velocity vector of B is parallel to this vector 3i plus j. So we can say the velocity vector of B is, let me use longer than 3i plus j. Direction vector means that. So we don't know how long it is, so let me use a constant. Now since we are using I and j for vectors, it is confusing if I write A or B or something. So best way is to use a Greek alphabet, lambda. This is the Greek alphabet, capital L. When we talk about alphabets, this is capital L in English, this is small letter L in English. So this is capital lambda. Is it this way or is it this way? I think it's this way, capital lambda. So capital lambda, and this is small letter lambda. So this is how we use Greek alphabets. So what we have to do now is we have to find the value of lambda. Now have they given us any information? So they have given that the speed of B is 2 square root of 10. That means modulus of velocity speed. So modulus of velocity is 2 square root of 10. So this is what we need to know. So let's start with A. So the first question is, find the distance between the two ramblers at midday. Okay, to find the distance between the two ramblers at the beginning, question number A, it is AB. So AB is OB minus OA. So OB is 5i plus 12j minus OA is 0 vector. Sometimes you can underline the 0 vector. So this is 5i plus 12j. That's it. Now distance is the modulus of displacement, so absolute value or modulus of AB is going to be square root of 5 squared plus 12 squared. Remember the rule? The rule was when you have a vector like xi plus yj, so the modulus is going to be square root of x squared plus y squared. So this is what we have to do. So this is going to be square root of 5 squared is 25, 12 squared is 144, so this would be 169. So this is 13 kilometer. I think the unit is kilometer. The unit is kilometer. All right, so this is the first question. So at the beginning, so we are talking about the initial position at midday, at the beginning, so you have to give the unit in kilometers. Question number B, you have to find the velocity of Bill. They're not sure whether you can find it, so that's why they have given you the answer. Finding and showing is ultimately the same thing. Showing means you can actually see the answer. So let's do this. So for question number B, we know velocity of B is going to be some constant of 3i plus j. That much we know. So if you write the modulus of this, it is going to be square root of multiply by lambda is going to be 3 lambda whole squared plus lambda squared. If you multiply lambda into j is lambda j, so this is going to be square root of 3 lambda whole squared is 9 lambda squared plus lambda squared. So this is going to be square root of 10 lambda squared. So we know the value of modulus of velocity, the speed, is 2 square root of 10. So I can write 2 square root of 10 equals to, if I bring the lambda outside the bracket, lambda square root of 10. So therefore square root of 10 cancels, lambda equals to 2. Now since you have the value of lambda equals to 2, you can easily find, hence velocity of B is 2 into 3i plus this, that means twice as long. So 3 to the 6i, 2 into j is 2j. So this is the answer. In question number C, we have to find at time t hours after midday. Remember, after midday, midday means t equal to 0. After midday, time is t. We have to find the position vector of B relative to A. So OB minus OA. So that's what we have to do. So this time I have to be careful not to make that same mistake. So question number C is going to be OB minus OA is equals to. Now before that, I think it's a good idea to write down the present position vector of both A and B. So for A, the present position vector is, if you remember, initial position vector, which is O, 0, plus velocity. Now the velocity of A is 2i plus 5j. So 2i plus 5j into time. Now for B, OB equals to, initial position vector was minus 5i plus 12j minus 5i plus 12j plus velocity we just found 6i plus 2j into t. So we are using the rule initial position vector plus v into t. So we have to find OB minus OA, which means AB. So that means we're going to write OB first. Last time we made a mistake. Last time I made a mistake, actually. We didn't make any mistake. So we have to write this first of all. Minus 5i plus 12j plus 6i plus 2j t. So this one minus OA is going to be, just let me get rid of this. Let me just write 2i plus 5j t. Okay, now we have to do some algebra. So if I just multiply this by t, it would be minus 5i plus 6tj minus 5I plus 6ti plus 12j plus 2tj. Now if I open the bracket, this will be 2ti minus 5tj. Okay, now I want to put all the I together and all the j's together. So this one is I minus 5i. So if I take I common, minus 5 plus 6t, so I and I common, then I have this another I minus 2t. So this is all the i's. If I take the j common, this would be 12j plus 2tj, so plus 2t. This would be minus 5t, and this would be the j common. So now if you write minus 5 plus 4t I, this would be 12 minus 3t j. So this is what we get when we simplify it. So let me check if is it minus 5 plus 4t. So minus 5, it is minus 5 plus 4t, and 12 minus 3t. So this is correct, 12 minus 4t. We can write this as 4 minus 5, 4t minus 5, no problem at all. Question number D says, show that the distance d kilometer between the two ramblers is this. So distance is the modulus of displacement, and we know the displacement is AB. That is the displacement vector AB. So OB minus OA is AB, and AB is this. So the next question D is, so let me do D here. Let me start here. So next question D is, we have to find the displacement. So if I call AB as the displacement, so absolute value of AB is going to give me square root of minus 5 plus 4t whole square plus 2 minus 3t whole square. So I can write this absolute value of AB is going to be d. If I send the square root to the other side, it will be d squared. So d squared will be minus 5 plus 4t whole squared. So a minus b whole squared. Let me write it like this now, 4t minus 5 for convenience, and this would be 2 minus 3t whole squared. Okay, let me come here and write it here. Okay, so it would be d squared equals to 4t minus 5 whole squared plus 2 minus 3t whole squared. So a minus b whole squared is going to be a squared, which is 16t squared, minus 2ab. So 2 4 is 8, 8 5 is 40, so 40t, plus b square, 5 square is 25, plus, so this is one thing, and let me break this. 2 square is going to be 4, minus 2ab is going to be 4 3 is 12t, plus b square is going to be 9t squared. Okay, now let me simplify. 16t squared plus 9t squared is 25t squared, minus 40t minus 12t is minus 52t. 25 plus 4 is going to be 29, so this is d squared. So let me check is the calculation is correct or not. 25t squared minus 112t plus 169. So where is the mistake? 8 5s are 40, then we have 25. Oh, the mistake is 4 3s are 12 plus this, so there is a mistake somewhere. Let me double check here. Okay, oh, this was 12, I wrote here 2, this was 12, that was the mistake. So it's very, very important to be able to recognize your own handwriting. So the problem is this is too cluttered here, the space is not there, but in your exam paper you have to make sure you write clearly, understand your own handwriting. So 12 squared, a minus b whole squared, 12 squared is going to be 144. So 2ab is going to be 24 into 3. Let me bring out my calculator. 2 into 12 into 3 is going to be 72, so this will be minus 72 plus 9. Now this is correct, so 16 plus 9 is 25 minus 40 and 72. If we add this, 40 and 72, this is going to be 112. So let me this will be 112, and this one here uh, 25 plus 144 is going to be 169. There we go, now it's correct. So minus 112t plus 169. Now the final one, using your answer to D, find the length of time to the nearest minute for which the distance between A and B is less than 11 kilometer. Less than 11 kilometers. This is an inequality. So this question number E, distance less than 11 kilometer means D is less than 11 kilometer. That means if I square both sides, D squared is less than 11 squared, which is 121. D squared is 25t squared minus 112t plus 169 less than 121. So 25t squared minus 112t, 169 minus 121 is 48. So this is plus 48 less than 0. So we have this. Now is it possible to simplify this? Can we divide anything? No. This is 25, this is 112. We cannot divide and simplify. So what we can do is we can try for middle term break. So middle term break is 25 into 48. So 25 into 48 is 1200. So now things seem pretty simple. 1200 means 100 into 12. So this would be minus 100t minus 12t plus 48 less than 0. That means if I take 25t common, this would be t minus 4. If I take 12 common, this would be t minus 4. So let's do it here. So this would be t minus 4, 25t minus 12 equals to 0. So therefore not equals to 0, less than 0. Okay, now there is a rule in inequality in C1, so you need some C1 concept for M1. They assume you understand the concept of C1. So if it is less than, you write it between, and you write the smaller value first and the larger value later on. So 12 by 25 is the smaller value and 4 is the larger value. So the time interval. So what was the question here? The question here, find the nearest minute, find the length of time. So we have to subtract the two in the nearest minute. So everything is in hour. So 4 hour means, is it in minute or in hour? Hour, per hour. The time is in hour. T hours, it's in hour. So 4 hour minus 12 by 25 is 88 by 25 hour. So time equals to 88 by 25 hour. Now if you multiply by this 60, you'll get the minute. So they said write down the answer to the nearest minute. So if you write down the answer of this into 60, that means 221.2 minutes. Now 211.2 minutes. So this is the answer, 211.2 minutes. So nearest minute usually means hour and minute together. So if the answer was in hour and minute, so this means if I divide it by 60, it would be 3 hour 3.52 hour, that means 3 hour and 13 by 25 hour. So 13 by 25 hour means you multiply it with 60 is 31.2 minute. So that means 31.2 minute means 31 minutes. So answer is 3 hour 31 minutes to the nearest minute. So